All right, we are looking at how to multiply rational expressions now and divide. So we need to start off again with numerical expressions and just talk about the process behind it. Maybe even one simpler than that. So just for a brief minute here, let's look at like a half times a fourth. What are we actually saying when we say a half times a fourth? Well, what are we saying when we say 2 times 4? Is a 2 4 times, right? And so a fourth of the time, what does that mean? Well, this means we've got 4 groups of 2, so this means we've got a fourth of a group of a half. So how do you have a fourth of a group of a half? So here's a half. If you have a fourth of that half, you only have 1/4 of 1/2, then in total you've got 4, 5, 6, 7, 8. You've got 1/8. So taking only 1/4 of half of something leaves you with an eighth. And so that means that just like 2 times 4 gets me 8, 1/2 times 1/4 gets me 1 times 1, 1. 2 times 4, 8. 1 over 8, 1/8. And so we find that multiplying, you can just multiply straight across. And so that helps me on a problem like 23, because I know that I can multiply straight across. So 15 24ths times 16 33rds is just going to be whatever 15 times 16 is over whatever 24 times 33 is. Now you're going to find that's a very big fraction. And I don't particularly want to have to reduce a big fraction like that. So a simpler way to do it would be to go ahead and say, well, since we just multiply across anyway, when we simplified things, we broke them down, they were easier to reduce. So what if I apply that here? What if instead of actually multiplying these together, what if I break them down? So instead of 15, what if I do 5 times 3? Instead of 16, what if I do 4 times 4? So what if rather than getting bigger, what if I go smaller? Instead of 24, what about 6 times 4? Instead of 33, what about 11 times 3? And I find that 3 divided by 3 divides to 1, 4 and 4 will divide to 1, and I see that 4 and 6 will divide to 2 over 3. Both of those divide by 2. And I'm left with 5 times 2 on the top, which is 10, over 3 times 11, which is 33 on the bottom. So 10 33rds is the same thing as these multiplied together, which, by the way, 15 times 16 is 240, and 24 times 33 is 792. So instead of you using big numbers and trying to simplify down to this, breaking them apart certainly makes it a lot easier. And just to prove that these are the same, 240 out of 792 is 33rds. So we got the exact same answer without having to do a bunch of extra work. Now dividing. Dividing can be a very similar process, but again, let's talk about why dividing works. Let's think about this again in a different way. We say we've got 4 divided by 2. Okay? Means we take 4 and we divide it into 2 groups. So we've got 2 groups of 2. Okay? Now 1/2 divided by 1/4, if we're saying we're taking 4 and we're dividing it into 2 separate groups, what if we're taking a half? But what if that 1/2 is only 1/4 of the group? If this is only 1/4 of the group, then I need 4 of them to make a whole group. So 4 of those halves, 4 halves is 2. Well, how do I get there? How does 1/2 divided by 1/4 get to 2? Another way to look at it, maybe this will help you. Let me write it like this. 1/2 can be rewritten as 1 divided by 2. 1/4 can be rewritten as 1 divided by 4. So what we're saying is 1 divided by 2 divided by 1 divided by 4. And if we apply that division similarly to how you would apply a subtraction, subtracting a negative would actually be adding, dividing would actually be multiplying. So really we could rewrite this as divided by 1, and then divide and divide, multiply by 4, 1 over 2, 1 divided by 2, and then here we've got divided by 1, but we've got multiply by 4. And you see what has actually happened is that this fraction has basically been flipped. It's been multiplied by the reciprocal. So when you're dividing by division, that becomes multiplication. And so that fraction ends up basically flipping. It's called multiplying by the reciprocal. So we could rewrite this as 1/2 times 4 over 1, and we already know how to multiply. So 1 times 4 is 4, 2 times 1 is 2, 4 over 2 is 2. That's how we get that answer. So knowing how division works, the problems can be solved the same way. So when we divide, we actually multiply by the reciprocal of that second fraction, because we're simply undoing what was done. Dividing by multiplication is division, dividing by division is multiplication. It flips. Sorry, hopefully that wasn't too crazy confusing. So, long story short, what that actually means we're going to do in the problem is we're going to rewrite it. We're going to say times 16/21 rather than 21/16. And so, again, it's basically what we did before. I can't really break a 7 down, but I can break the 16 down into 4 times 4. I can break the 12 down into 4 times 3, and this 21 down into 7 times 3. And then I see that I can divide out a couple 7s, divide out a couple 4s, and I'm left with a 4 on the top and 3 times 3, or 9, on the bottom. So 4/9. So let's try this out. 7/12 divided by 21/16 is 4/9. And by the way, 7/12 times 16/21 gets me that same answer. So you can see that dividing and multiplying by the reciprocal provide the same result. And since we already know how to multiply, the easiest thing to do is to switch it to a multiplication problem and then do just what we did on 23. So let's apply that here to 25. So again, we know that we can multiply straight across when we have multiplying fractions. So here I can multiply 3a times 8. And again, I'd rather not actually multiply them together. I want to leave the number smaller so I can see if I can divide anything out. And the denominator is just multiplied across as well. 10 times 8a squared. Well, I see that I can divide out those 8's, and I can divide out an a with one of those a's, leaving me with only one. And that's all. So I'm left with a 3 on the top and a 10 and an a on the bottom. It can't simplify any further, so that's it. So multiplying and dividing is really just treating it like one big fraction, multiplying it all together, but leaving it separate, and then just simplifying like we did from the very, very beginning. So 26. It's a division problem, so I immediately think, okay, division is just multiplying by the reciprocal, so why not go ahead and do that? And then I'm going to go ahead and leave everything separate in an effort to simplify anything I can. And actually here, 7's prime. 7's not going to go into 6 or 9. There's no variables to cancel because they're all on the same side, so there's really nothing I can do here, so I might as well just put it together and call it a day. So 9 times 6 is 54 n to the 4th, and 7 times 7 is 49. This is one that just didn't simplify, so we just multiply it together, call it good. Okay, so now we move on to 27. 27, 8p minus 72 times 4 over 4 times p minus 9. Okay, once we start getting into these binomial and trinomial expressions, these quadratic expressions like you see here on 28, we need to start breaking them down using factoring techniques. So for example, when you've got a binomial here, we can factor out something they have in common, like an 8, and that leaves me with a p minus 9. I like to just write it above so I don't have to rewrite the whole problem. So 8 times p minus 9 times 4 on the top over 4 times p minus 9 on the bottom. So I have p minus 9, that divides to 1. I have a 4 on the top and the bottom, that divides to 1. So that leaves me with only an 8 on the top and nothing on the bottom, but you can't say nothing. For anything divided by itself is 1, so technically a 1 remains on the bottom. So 8 over 1 is just 8. So now 28. 28 is a division problem, so I'm going to immediately rewrite it as a multiplication problem and make sure that I'm multiplying by the reciprocal. Now, instead of me rewriting all of that together, that's going to just be obnoxious to basically write the same thing over and over again. One thing that I like to do to try to save me some time and space is just kind of group it together and use what I already wrote to turn it into one big fraction. So we're multiplying the top together, we're multiplying the bottom together. It's going to end up looking like that anyway. And then I need to look for things that can factor. The first term, or set of terms here, can't factor the first expression. The second expression can factor. So what factors of negative 4 will add up to negative 3? And I know that negative 4 and positive 1 will do the trick. And again, to save myself some space, I'm just going to write the factors above it and cross it out. So on the top, just to recap, I've got p plus 8 times p minus 4 times p plus 1. That's my numerator. My denominator, I need to factor this out. It's the exact same numbers. I guess I could have paid attention to that before I factored anything and just divided them out immediately, but it is also p minus 4 and p plus 1. Obviously 1 by itself doesn't do anything, nor can it factor. So I'm left with the denominator of p minus 4 times p plus 1 times 1. And I see that the p minus 4's divide out. I see that the p plus 1's divide out. So I'm left with a p plus 8 in the numerator. And I'm left with just 1. 1 times 1 times 1 is 1 in the denominator. So p plus 8 divided by 1 is just p plus 8. Alright, so now we start getting expressions that have more things that you can factor out. So it's the same process, but it's just more things. So again, instead of me rewriting this multiplied together, I'm just going to kind of cheat a little bit, and I'm going to pretend that it's already been done. So multiplying those together would yield this. I'm not actually going to multiply. I want to leave them broken apart. And not only do I want to leave these broken apart, I want to break them down even more. So starting in the top left, this is quadratic. You could just go about factoring, but 7 times negative 42 is going to yield a pretty big number. So if I notice that 7 goes into all three of these numbers, you could actually just factor out a 7 and make it a lot easier. You're still going to want to factor this, but by factoring out a 7 first from every term, it's going to be a lot easier to apply your factoring technique for a quadratic. So now it's just factors of negative 6 that add up to negative 5, much, much smaller numbers. And I know that negative 6 times 1 is negative 6, and I know that it adds up to negative 5. So b minus 6 and b plus 1. And then b minus 9, can't factor anything out of that. So on the numerator, I've got 7 times b minus 6 times b plus 1 times b minus 9. I'm not going to multiply that all together. I want to leave them separate like that. And then on the denominator, I've got b minus 7. Can't do anything with that. But here, 7b plus 7, I can factor out a 7, leaving me with b plus 1. So the denominator is b minus 7 times b plus 1. So I'm looking for things they have in common. I see they both have a 7 that divides to 1. They both have a b plus 1, which divides to 1. And I'm left with b minus 6 and b minus 9 on the numerator. And I'm left with only a b minus 7 on the denominator. And because it was the only expression left, I didn't need parentheses because it was already by itself down there. So that's 29. That's as simplified as I can get. And just for the record, you could multiply this out on the top and leave it in standard form, but there's no reason not to just leave it in factored form either. It shows that there's nothing to simplify. All right, number 30. We're multiplying again. So again, I could go ahead and rewrite this expression multiplied together, but that seems like a giant waste of time when I can just write them multiplied together and not have to rewrite everything. So now I'm looking for expressions that factor. So the top left expression can't factor anything out of that. Top right expression, I'm looking for factors of 18 that add up to negative 11. So how about negative 9 and negative 2? So there's my numerator, 3 binomials. My denominator, I can factor a 2 out of this bottom left one at least. Not much, but it's something. And then I can factor factors of negative 24 that add up to 5. So I've got, 8 and negative 3. 8 times negative 3 is negative 24. They add up to 5. So we're rewriting that expression. So I've rewritten my quadratic expressions into factored form. And now I can look at everything together, look for anything on the numerator and the denominator that divides to 1. So x minus 3's will divide to 1. My x minus 9's will divide to 1. And that leaves me with just x minus 2. I didn't need those parentheses because that's all that was up there. Over 2 times x plus 8 on the denominator. All right, moving on to 31. Hopefully it's getting simple by now. Notice this is division, but remember division is just multiplying by the reciprocal. So it may be obnoxious, but it would be a good idea to go ahead and just rewrite the whole problem. So I'm going to rewrite the first expression, but the second one, I'm going to write down the reciprocal. So we're multiplying by the reciprocal. Now again, when you multiply, here's where we've already rewritten it once. Let's not do it again. We say we multiplied it together, but we're not actually going to combine it. We're going to leave it just written separately as this times this. And instead of me putting it together, I'm going to break it down even more, just like the other ones. So starting on the top left, all of these will factor in some way. So on the top left, factors of 9 that add up to 6. We should be good at factoring by now. 3 and 3 will make 6. Here we've got a 9 that can be factored out of both terms, leaving me with an a minus 4. The bottom left, we're looking for factors of 32 that add up to negative 12. So 8 times 4 is 32. So negative 8 and negative 4 will add up to negative 12. And then finally again here 3 and 3 will make 6 and multiply to 9. So I break everything down into as small factors as I can, and then I look for things that will divide out. So a plus 3 divides to 1, as does this pair of a plus 3's. And then I've got a pair of a minus 4's that will divide out to 1 as well. So my numerator consists only of a 9. My denominator consists only of an a minus 8. And then finally, last problem on this set, it's another division problem. So I'm going to rewrite it as a multiplication problem, but I have to multiply by the reciprocal. So I'm looking for, go ahead and combine this into one multiplied fraction. Looking for expressions that will factor. First one doesn't. Second one, those are huge numbers, but if you'll notice, they all have a 21 in common. So let me factor out a 21 first. And by doing that, it actually becomes a very small quadratic expression, tiny numbers that we can easily factor. So factors of negative 2 that add up to 1. How about 2 and negative 1? So I can rewrite that expression as 2, and negative 1, m plus 2m minus 1. So I kind of ran into my problem there, but my numerator is m plus 4 times 21 times m plus 2 times m minus 1. All of that on the numerator. My denominator, I can factor a 3 out, leaving me m plus 2 here. And I can factor a 28 out, leaving me with 1 minus m there. So now looking for things they share. 21 and 28 can both be divided by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. They both have an m plus 2. And now let's see if we remember what to do here. We've got an m minus 1 in the numerator and a 1 minus m in the denominator. These are opposite factors. Opposite factors don't divide to 1, they divide to negative 1. So we can divide them out, but they will divide to negative 1. I'll just put it over here. So my numerator consists of m plus 4, negative 1, and 3. Everything else has been divided out, so that leaves me negative 3 times, I'll go ahead and write that. Negative 3 times m plus 4, and then my denominator has a 3 times a 4, which is 12. Now what I didn't notice up here is that I had 3's there that could have divided out as well. So if you don't notice that, hopefully you see it when you put it back together. So that divides to 1. 12 divided by 3 divides to 4. So I can rewrite it one more time as negative 1 m plus 4 divided by 4.